Good afternoon, everyone. We hope that you and your loved ones are staying safe and healthy during these challenging times, and would like to thank you for tuning in to our presentation today on counter pressure filling. My name is Connor McCauley. I'm alongside my colleagues, Mark Saylor and Kyle Kelleher.
For those of you who aren't familiar with Pneumatic Scale Angelus, we're a global supplier of packaging equipment serving many different industries, including everyone from small craft brewers to large food and beverage companies. Connor, myself, and Mark Saylor cover the US regarding craft beverages, while Tom Bowditch covers Europe and the UK. We built a dedicated team here for craft beverages, including sales, engineering, project management, assembly, and field service.
In today's presentation, we're going to take a deep dive into counter pressure filling. And at the completion of this recorded video, we will be doing a live Q&A session. So without further ado, let's get started.
Yep. Hello, everyone. I'm Mark, as Connor and Kyle introduced. I cover our West Coast. I'm going to break down here the agenda that we're going to be kind of going over today. We're going to start with a refreshing course, sort of talking about just filling in general, the fundamentals of that process and other technologies that are out there. Then we're going to get more into counter pressure, and in particular, our approach to what we did to set up our counter pressure filling machine. Then we're going to kind of cover what we've learned out there in the field using that technology and that kind of knowledge we can pass on, that knowledge and experience and stuff that we'd like for you to learn as well. And then we're going to kind of look more at, is counter pressure the best filling option for you and your application, what you're looking to do?
All right, so let's talk about what you want to achieve. When you're canning, the most important things are to preserve your quality and the taste of your product. You also want to extend that shelf life so your product stays good on the shelves as long as possible. It's important to protect your most valuable asset, which is your brand reputation, because once the product leaves the brewery, the only way to protect it is with the package that you're putting it in. So you want to put it in the best possible package so it stays good as long as possible, and tastes the way it's intended to taste. So in order to achieve that, you need a filling machine that enables you to customize your production parameters to your unique products. You need to ensure proper hygiene to avoid product contamination. You need to achieve consistent fill volumes and minimize loss during packaging. You want to limit dissolved oxygen levels. Again, going back to that shelf life, you want your product to stay good as long as possible. You need to maintain consistent carbonation levels so that product is the same each time that customer goes to consume it. And then you need to achieve your desired throughput. So you need to know the speed that you need to package at according to how much product you're putting out in the market. And then ideally, you want to deliver the freshest possible product to your customers. You want them to taste the product the way it's intended to taste. All right, so we're going to touch on atmospheric filling, just a quick refresher. Product is going to flow from a filler manifold directly into an open can. So typically, you're going to run the product from your bright tank directly through the filler into the open can. Typically, atmospheric machines are simple and easy to maintain and operate. You're going to create foam as a natural part of the filling process, so that CO2 is going to want to break out of the product during filling with an atmospheric machine. So the variables on the atmospheric machine that are most important are the temperature and pressure of the product. So you need to have that, typically you need to have that product around 35 degrees. And then you're going to have that carbonation limit of around 2.7, 2.8 volumes of CO2. Typically, these atmospheric fillers are suitable for low speed inline production, and they can be more cost effective than a higher priced counter pressure solution. And again, you're gonna run into those limitations of temperature and pressure. So good for products like beer and cider, for example.
And when counter pressure filling, the product flows from a pressurized tank into a pressurized can. Typically, it requires a greater initial investment due to the overall cost of the filling technology. You also want to have a technically savvy operator with packaging experience because there's more variables to dial in. You also want to consider an expert supplier, someone who understands the technology behind true counter pressure filling, and doing so could save you a lot of money in the long run due to increased efficiencies. you can fill a much wider range of products. So anything from still to higher carb beers, sodas, ciders, kombucha, seltzer, etc. There is a lower CO2 loss in DO pickup than you would find on an open air filler. You also have a lot more control over several production variables such as temperature, pressure, purge cycles, carbonation levels, since you are purging or filling into a purged sealed container that is not exposed to oxygen. And counterpressure filling, it's the industry standard across the board for high production environments. Typically less product loss as compared to open air filling.
All right, so now we're going to look at kind of counterpressure and sort of the relationship between temperature and pressure and how it's going to affect how much carbonation you can keep in solution. So when we say volume CO2, we're talking about the carbonation levels, the amount of carbonation you can keep in the beverage. So those, how much you can achieve is going to be a direct relationship of temperature and pressure. The higher the pressure you can achieve, the more carbonation you can get. And the colder the temperature you can achieve, the more pressure you can, or the more carbonation you can get in a product. So you can see the chart there on the right, you have that pressure variable on the top, and then you have the temperature on the left-hand side. Basically, you can look at your setup and the variables that you can achieve, and you find what's your max pressure, what temperature you can reasonably run your product at, and that's going to tell you, what carbonation you can expect to achieve in solution. And it can also give you an idea of where you'd need to get to be able to achieve a higher carbonation. So when you're packaging, and you imagine you're going from your bright tank to a filler, your pressure that product's under, you want to, it must be met or exceeded all the way through that, on the way to the filler. If you go over a longer fill line, that pressure is going to drop. One of the ways we can kind of combat that is we have a little a PD pump that you essentially attach to your bright tank. So that almost pressurizes the fill line itself, kind of helps fight that pressure loss while you're doing this process. So the other thing about pressure, or the other thing about the counter pressure technology, it allows you to use a much higher pressure. And then that way you don't need to be, say, as cold. If it's tough to achieve that low temperature, on a hot summer day, you can't get that tank temperature down. So having that kind of flexibility in the amount of pressure you can keep the product under, that greatly opens up the opportunity for you to fill at different ranges in there as you need. Then basically, kind of the summary, in the end here, you can calculate what you can achieve by using, it's called the ZOM chart. Or the similar CO2 chart on the right. It just kind of shows you again that range of, here's the temperature you can hit, here's the pressure you can hit. That's going to tell you, this is more of like a scientific approach of what you can achieve carbonation wise for your beverage.
Counterpressure filling is the process of pressurizing a container with CO2 or nitrogen to equal pressure of the incoming product. Then in a controlled manner, we relieve the pressure in the container to allow the liquid to displace the gas. The point of this is to maintain pressure on the liquid to avoid the gas from escaping or breaking out. All true counterpressure fillers utilize a product supply tank located above the filling heads for smooth gravity-fed fills. And it's also critical to maintain a consistent head pressure. The distance between the tank and the fill valve does not change regardless of the size of the can.
All right, so now we've talked about how to fill your product. What's important after that? Let's not forget about the seam. So the importance of double seaming, basically that is, as Kyle touched on earlier, protecting your product. This is the last line of defense before your product gets out there into the field and what the customers are going to drink. It's that if it's done correctly, that's where you get that with a nice cold can, they crack it open, and it's that nice refreshing experience that you want them to have. So basically, as we've touched on here, double seaming is the process of attaching the can lid to the can body to create that airtight closure. It's a 5-layered hermetic seal. Kind of looks like our logo down there in the left corner that you can see. So for beer and beverage products, any air or oxygen that gets in there, that's the enemy. The more oxygen content you have, it's going to alter the taste of of what you've done to make that product, and also going to reduce your shelf life the more oxygen you have. So, one of the best ways to fight this is, you want to make sure you recognize the defects or the errors that you have in the seaming and correcting them. Or ideally, you have a high quality seamer that's going to prevent those from happening in the first place. Again, protecting that your can before it gets out there. So, to do that, you want to make sure that seamer design, you have the adjustability to accommodate all the different types of cans that are out there in the market today, and the different end sizes, and the materials themselves. Cans have become much lighter weight over the years. That's something that we've seen change, in all of our experience. One of the ways that we can fight that is with our lower lifter plate is on a can itself as well, and it has an adjustable spring pressure. So, even if you were to say buy a machine and maybe cans, they take off another half gram, become even lighter. Having that adjustable spring pressure is a way where you don't, you can reduce the amount of pressure you're applying upwards. So you don't want to, just jam and crinkle the can in there. So having a machine that can kind of take all those different variables into account and let you seam properly, don't forget about that.
In this illustration, we're going to walk you through the step-by-step process of counter pressure filling. So step 1, the can is loaded and centered underneath the filling head. Step 2, the filling valve seals to the top of the can. Step 3, the can is flushed with CO2 to remove oxygen, and this step can be performed as many times as needed. After the can is flushed with CO2, the pressurization phase begins. This is the point where we get that equal pressure in the can and the product supply tank. You can see in the illustration the product is being filled here in step 5 on the side of the can to gently fill without any turbulence. Step 6, the filling cycle is completed to the accurate fill level. For our CB50C machine, we use volumetric flow meters with 1 milliliter accuracy. Step 7, we start the pressure relief process, also known as snifting. It'll pause here after the first sniff. Then you have the option to continue the snifting process as many times as needed for your particular product. I'm going to run through that pressure release one more time. And finally, the can is released from the fill valve. I'd also like to emphasize that there is no vertical can movement, which can cause product agitation and oxygen pickup. And finally, the can exits the filling environment.
All right, so here we're going to take a little bit deeper dive into each step of the process. So step 1, can loading. You're going to have the cans flow into the filler. We control the cans and center them with a scalloped back guide so that they're centered underneath the individual filling heads. Like we mentioned before, this is done individually on our machine. So if one seal is not created on one of the cans, that individual head's not going to fill, so you don't experience any loss there in that scenario. But step 1, cans are going to load and center underneath the filling heads. Step 2, valve to can seal is created. So again, those filling heads are going to come downward and seal onto the cans rather than the cans being lifted up to the filling heads. Step 3, CO2 flushing. This is commonly referred to as the pre-purge. So we're going to push CO2 through the system, forcing out all the oxygen. That oxygen is going to vent to atmosphere. Headed over to step 4. All right, step 4, we have the can pressurization, as Connor talked about. So we're gonna create equalized pressure between the product tank and the can. So that allows the product to fill with the gravity fill. Step 5, we're gonna begin the product filling. So we're gonna gently fill with gravity down the sides of the can, as illustrated in yellow there in the drawing. At this point, the CO2 is going to vent back up into the product tank as shown in blue. Step 6, end of the filling process. So when your desired volume is hit, again, we fill with the magnetic flow meters. So it's a volumetric fill plus or minus a mil. You can also fill to a level or fill with timings, but again, we're going to use the mag flow meters. So plus or minus a mil. Once that desired volume is achieved, you're going to break the seal. And step 7 is the first pressure relief. We call this the sniffing process. So that's the controlled release of pressure. You might think of a 2-liter bottle of soda. You slowly release that seal rather than just taking that cap off as fast as possible. So slowly control that release of pressure. All right, step 8 is your first pause. So this pause allows the product to stabilize after the sniffing process. Steps 9 and 10 are optional. They are repeats of steps 7 and 8. And these can be repeated as many times as needed, depending on the product, if you're still experiencing any breakout. And then step 11, the can release. So now that we have a stabilized product in the can, we break the seal. We raise the valves, again, as to not agitate the product, so no lifting of the can. And we look for a slow, controlled generation of fob after the release. So we don't want to experience any kind of massive breakout after the seal is broken.
All right, now we're going to play for you here a video kind of the counter pressure filling RCB50C machine in action here. So as you can see, the cans are coming in. The filling process is happening up front there. Then yeah, the empty can comes in, begins to seal, go through the fill itself. You know, one of the things again with the counter pressure and kind of what Kyle just touched on is that sniffing process. So you can see there as the cans are leaving how clean that fill is. There's no burst with the kind of foam popping out once that seal is broken. You get a couple fish eyes there, but we have some gassing technology to combat that too. Again, yeah, look here on the right-hand side as these cans are done filling, you know, how clean the fill process is. You know, with how clean it is, all the levels are the same, you know, as Kyle touched on, we're precise to 1 milliliter with our mag flow meters. Just a nice clean filling process. This is what we like to see in action here. So with that, you know, if we all the kind of pressure technology that we've used kind of coming together, we can hit up to 5 volume CO2, which is extremely high. You know, typically you'd want to start looking at counter pressure once you're above, you know, 3.0. You know, 5 is very high. There's not many products out there that are that carbonated. But if you were to need to run that, you could do so in our machine. So after filling, we have our underlid gassing, or we have our gassing tunnel there on the left, and then our underlid gassing on the right is just another little burst of CO2 right as the lids are being put on. Again, just more ways to combat oxygen pickup. So now go down from there. You end up at the seamer. As you can see, our first and second operation levers are in action here. The can's being raised up by the lower lifter plate to meet the chuck. We'll get a better look here. So, you know, through this whole thing, we're using our Angelus tooling. It's industry leading. You know, if you were to say, look at your seaming spec sheet from Bowler Crown, they're going to reference an Angelus tooling number. They're talking about us, you know, when they're doing that. You can kind of see a part number there on the chuck itself, right in the middle. You know, this is that area where you've done all your filling, all your beverage producing. You know, this is the last line of defense. You want to have the best possible seal on this package to preserve everything you've done out there, you know, and make sure that product gets to the customer as you intended it.
So counter pressure, what does it actually mean? We've seen this word thrown around within the craft industry over the past year or so, with a lot of companies introducing their own spin on it. What we know is that true counter pressure filling in the high-speed environment requires equal pressure in the can and a product supply tank to maintain carbonation solubility throughout the process. If you were just to pressurize the can itself, you're relying on back pressure that a feed system must overcome. This method may mitigate some foaming, but is not considered true counter pressure filling. True counter pressure filling requires a tank to be located above the filling heads to ensure smooth gravity-fed filling, which we've talked about a lot so far in this presentation. If the product becomes agitated, you'll see a loss of carbonation, you'll see increased DO levels. By gravity filling, you're allowing the product to stay at the same flow rate, regardless of pressure. Earlier in the presentation, we mentioned snifting, which is the process of slowly relieving pressure from the can in as many steps as necessary to ensure the product doesn't break out when breaking the seal with the filling head. So if you think about opening a 2-liter of Coke and what would happen if you quickly took the cap off, as soon as that product hits the atmosphere, it wants to foam up and spill over. By snifting the can in a controlled manner prior to breaking that seal, you're able to control the breakout.
All right, so we're going to touch quickly on safety and hygiene. So safety, starting with safety, when pressure in your tank is above 15 psi, you need to make sure you have a certified pressure vessel. You can find more information on pressure rated vessels on the Brewers Association website. Another thing you might look for is a system with safety interlocks on the doors. That way, if you open the filling system, it's going to cut out, so there's no danger in anyone opening the system and sticking their hands in or anything like that. Jumping to hygiene, touching on snifting again. So snifting is how we control the foam. This prevents collection on the bottom of the filling head for possible product contamination, prevents any kind of dripping from the nozzle into the can, which can introduce unwanted oxygen into the can underneath the filling head. A pressurized vessel and optional pump allow for higher velocity CIP, pushing CIP solution through the fill heads faster to achieve a higher level of cleaning. And while we're at it, if your bright tank doesn't have capacity to push the product, being able to pump the product from your tank farm to the filler is absolutely critical. So you might want to look for a pump and filler that can seamlessly integrate to achieve that.
All right, coming back to that temperature and pressure stuff that I talked about before. So why temperature matters. So when you have if you're able to hit a higher pressure, again, that allows you to fill at a higher temperature. So there's your flexibility. You know, not everyone can keep their tank at 30 degrees, 31 degrees to be able to run some of these higher carb products, you know, to get that clean fill. When you're controlling, again, we're going to come back to the snifting here because it kind of does factor in. You know, not only are we snifting in the first place, but you can customize that. You know, and that's very key for the variations in temperature you might have for your products compared to atmospheric filling. You know, you can add that second sniff cycle. You can change how long that sniff is. So as the 2-liter analogy again, you know, if it depended on how, you know, when you have that 2-liter bottle and you shake it or you've dropped it, you know, it's super, you know, pressurized, you know, that kind of factor, we can account for that, you know, by adjusting the sniff process. And that sort of is affected by your temperature coming in. So the other thing with temperature that's really good, the flexibility that counterpressure offers with higher temps, you know, you've got some other benefits here. So your startup is much quicker. The first can, you don't have that process of going through and maybe opening the fill heads and doing a couple of fill cycles to lower temperature. You know, your first can is going to be, you know, clean right away. It's independent of that temperature. You don't have that, you know, that hot temperature to start with. Basically, you can start filling and running production as soon as your product gets to the machine. You know, there's no need to flush that product through to cool down your fill lines, to cool down your fill heads. And, you know, what does that mean? It means you're not losing product. You're not just throwing it down the drain to do that cooling process. You're able to run right away. Then, you know, the other thing with the adjustability here is that as you do that, or as you begin running and it does cool down, you can adjust certain parameters from the HMI, you know, and that not have to stop production. The other thing with that product loss, you know, where do you get it? Typically, it's when, say, you're changing a pallet over and you're not able to keep running the filler, or when maybe downstream your labeler, you're changing a reel over. You know, anytime you have those stops in front or behind of your filler seamer, you know, the product that's in your filler manifold and the fill line itself on the way to the machine, that product's going to heat up a little bit, going to warm up. But, you know, with counter pressure and the flexibility that we're offering here, you know, that you don't have that, you know, battle, you know, as you're starting back up again. It's, you know, the temperature change isn't affecting that as much. You're not getting that breakout when you restart. You're able to, again, just start back up, clean fills, ready to go. So it's a good way to kind of look at all that here. There's a lot of benefits to, the counter pressure technology.
In the brewing industry, we are very concerned with DO levels. So knowing that protecting your beer throughout the packaging process will protect your brand once it leaves your facility, there is a high level of precision that needs to take place in the canning environment. With knowledge of the high-speed filling industry and our experience designing, building, and installing fillers all across the world, we have learned a number of critical things that must take place. First, individually sealing all the fill heads at once. We have precise control over each can, regardless of variation in can height. Sealing the can and purging and filling into a CO2-rich environment allows for no additional oxygen to be introduced. Loss of product is reduced and efficiencies are much higher because the individual can won't fill unless a proper seal is achieved. Each filling head is controlled individually, again, so will have no impact on the overall production. And counter pressure filling actually reduces the consumption of CO2 as compared to open air fillers because we are recirculating that CO2 during the filling process.
All right, so let's touch on the connection to high-speed beverage. So typically on the high-speed side, the preferred filling method is counter pressure, as we've been discussing, and the preferred sealing method is a mechanical cam-operated machine. So we have more than a century of experience in high-speed canning technology, up to 2,000 cans per minute. We were able to leverage that experience and that technology to create inline 50 can per minute machines and 100 can per minute machines with the same quality of fills and seams that you would get at 2,000 cans per minute. For the precision required in can to filling valve positioning at higher speeds, a rotary design is preferred. So you don't have that intermittent starting and stopping. You're able to continue filling on a rotary platform at those higher speeds. We find that with our experience, inline counter pressure technology performs efficiently up to 50 cans per minute, but rotary expertise will prove beneficial at those higher speeds.
All right, so we've kind of thrown a lot at you here. So let's look, sort of a couple questions here to ask yourself, is counter pressure filling the right choice for you and what you're looking to do, for your packaged product? All right, so, one of the first things you want to look at is the variety of products from still products to higher carb products. Keep in mind, even if you're not running it currently, it's something that you're looking to add in the future, in what you're looking to run. You want to make sure you have a filler seamer that is capable of doing that, if that is something that's in the future plans for you. Then the actual products themselves. Do you have very difficult to fill products that are very high carbonation, above 3.0, things up to 4.1 volumes, such as seltzer, sparkling wine, kombucha, some of the higher carb beer that's out there, RTD cocktails, craft sodas, the list goes on and on as we've continued to see more and more products kind of, be introduced there in the field and whatnot. So having a machine that is capable of doing that, or on the other end of the spectrum, a still product that you're looking to fill at a higher temperature for like a hygienic fill, counter pressure technology is ideal for that too. So keeping in mind that whole range of products that are out there in the market, maybe you want to do co-packing, anything like that, just sort of keep that in mind when you're making your decision. So now, do you want to fill nitrogenated products, such as something that has a widget can? When you're looking to do that, the can suppliers themselves that supply those widget cans have a lot of requirements that they're going to ask you to achieve to be able to properly fill a widgeted can, to their specifications. A lot of that's hitting a very high purge cycle, or very high pressure in your purge cycle, and that's going to basically, you need that to be able to flush the CO2 from the can and the actual widget device itself. What kind of bowl pressure in terms of, when we say bowl, we're talking about the filler bowl we mentioned earlier, mounted above. Having that, basically there's a lot of points that they want you to be able to do that you need that customization from counter pressure to be able to hit. So if you want to do the widget stuff, you got to make sure that you are, you have that capability. Another thing to keep in mind is, are you looking for a very hygienic filling technology to reduce, any kind of contamination that could come into your system? Are you looking for the highest quality fills, the lowest oxygen pickup? Is that, where is that importance, ranked to you? And then, do you want to have that additional control over your production parameters and variables, in terms of what you can produce? I've got a lot of things to keep in mind, but just sort of, some good questions here to ask yourself, when you're looking at making a decision in terms of packaging technology for you.
So if you decide that counter pressure filling is something that you would like to do at your facility, there are some other factors you'll need to consider before making that investment. Does your brewing process have the ability to run at higher pressure? If you want to hit those higher carbonation levels in the can, you need to make sure your current equipment can do so. If you are able to run at a higher pressure, can you maintain those levels between the tank and the filler manifold? Also, strongly take into consideration the ability to CIP the machine. So if you're a brewery who needs to run seltzers, sours, and a number of different products, you may want to have a dedicated set of fill lines for each unique product. Also want to make sure that you purchase a machine that uses stainless steel nozzles versus the inferior materials, such as plastic that will leave residue behind and can't be properly cleaned. Your product mix, it's also important you communicate that with your can supplier, due to different pH levels of the product that could cause corrosion inside the can. So that's just something that you want to keep an eye out and make sure you communicate with them as well.
All right, so just wrapping it up with our full craft beverage portfolio here. You can find additional information on all these machines at beer-canning.com. So first machine there, we have our CB50F open air or atmospheric filler. Again, that's geared more towards your lower carbonated beverages below that 2.8 threshold. So your beers, ciders, things like that. Then you also have our CB50C, the counter pressure unit we've been talking about throughout this presentation. That's going to be geared toward your wider product mixes with higher carbonated products. Like Connor mentioned earlier, that can handle anything from still products all the way up to that 5 volume CO2 threshold. Then we have our CB100F. So that's the atmospheric machine as well, 12 filling heads, 2 seaming heads, 100 cans per minute on a 12 ounce. And then you have our CB244 rotary line. Again, that's going to be a counter pressure filler with a mechanical seamer. That'll run up to 250 cans per minute on a 12 ounce. And then the next offering that's going to be coming out at CBC in May is going to be the CB100C, so the counter pressure version of the CB50C, and that'll be on a rotary platform as we discussed earlier. So check back at the Beer-Canning site in the future to get more information on that.
All right, so we've talked about a lot about the filling side of everything here. We dove a little bit into the seamer, and if you want to learn more about that, we've actually already done a great series of videos, and they're all posted to our Facebook website. We did these through the Craft Beer Professionals Conference prior, so we had kind of we call it the essentials of seaming. So our first episode, we touched on craft beverage canning and double seam integrity. Then we hit on episode 2, understanding the tools, measurements, and how to evaluate your seam. And then on the third episode, we kind of took both those 2 prior videos and sort of discussed putting everything together, using everything you've learned and how you bring that into your own, say, packaging environment if you're starting up. So some great videos to check out. We'd love to have you, watch them, learn some more about the seaming process if you're interested.
Here's a brochure just providing some more information on our CB50C filler steamer that we discussed numerous times today. This ad is in your program detail for the presentation. Please check out that link shown for an in-depth look at the machine. We really appreciate you guys joining us today and hope you have a great year.
Thank you, everybody.